All right, so this is continuing on with class 6, and this is sample problem 3.3. And once again, I'm going to get the reactions instead of the equivalent moments. So the sample problem in the book shows you equivalent moments. Here we're going to do the the reaction. And I'm going to do it 3 separate ways. And I think I'm going to make this as part of a quiz, but it's not really a quiz, just a interactive type of thing. So here we go. I'm going to draw this 3 separate ways that are possible. So my first way is going to be what I prefer to do. Second way is going to be, it's going to be a pretty convenient way to do it as well. So it's an alternative way. No problem. And then lastly, we're going to have the kind of ridiculously geometry intensive way right here, right? So those are my 3 things that are happening, and here's what here's essentially what I'm going to do. My first way, my preferred way, is to break this, as we see this thing, into forces that align right here. So what I ended up doing was this is 30, right? And it's going to be times the sine of 20. And this is going to be 30 times the cosine of 20. And in terms of reactions, probably going to go downwards with the Ry, probably going to be to the left with the Rx, and then a moment reaction. You'll notice that the forward loads on this are tending to make it go clockwise, so our reactions at O is going to be counterclockwise, right? And so the distance that we would use for this is simply going to be this right here, right? Simple. And so that's going to be the 3 feet. So if we take the summation of moments about O right here, all we have to do is say, okay, that's a negative 30 times the sine of 20 times the moment arm, which is going to be 3 feet. A lot of times we'll use inches. We could use feet sometimes. It's totally fair. Plus reaction MO. That's the specific reaction. It's up here. Remember, that's all the moments about O. The one we're drawing down here is a specific one. It's going to be equal to 0. We would get MO is equal to 30.78. And I prefer to go foot, pounds, but sometimes people go pounds, feet. Doesn't matter. Go either way. But that's the reaction that's happening, that's holding this thing in statics, because this is statics in place. Now, if another alternative way that we could approach this would be to, and this would be good, there's nothing wrong with this, to break these forces, right? Because we could actually break these forces into X and Y components onto the thing. And if looking at this right here, what we'd need to do, and I usually make a little side sketch, I recommend that, right, for things like here. Put this up to here, right, and we have other lines. I'll come up right to there, right here, right here we see that this is 50 degrees. Right here we see this is, nope, take it back. Can I erase it? I erased the line. Damn. My eraser just wouldn't let me do it. Alright, so I like to use green for geometry stuff. This right here was the 20 degrees. Well, then the rest, here was 30 degrees, obviously, from the 50 and the 20. And then right up here, you could say that this is 40 degrees. So you could use any different method of combination of those. But in breaking this thing apart right here onto this load, we could say that this was 30 times the cosine, right? Cosine of 30, right? 30 pounds. And then right here is 30 times the sine of 30 degrees, right? And then putting all those reactions back onto there, it becomes obvious that these were up and down. But now when we want to go for the geometry of this, right here, we could call this the dy maybe, and then we call this one bump. Here's the dx, right? So what we would say now is the sum of the moments about O, right? We would say, okay, I take a look at this 30. It's going to be negative 30 times the cosine of 30. This distance right here, that distance, that dy, maybe I want to write this over to the side somewhere. The dy is going to be 3 feet times, let me see, I get this right. It's going to be 3 feet times the sine of 50. And dx is going to be 3 times the cosine of 50, right? So what I end up going to write for this is this for the x direction force, that's going to be the y direction thing, and so that ends up being 3 times the sine of 50, right? And I'm going to come down to a line over here. Now I go for the y direction, and that's actually going counterclockwise, right? Where the x direction force is actually making a clockwise. That's why that's negative. But now this one is actually going clockwise. So we go 30 times the sine of 30, and I just messed up. This should not be a 30. This should be a 3. And then notice they're going to be the dx, 3 times the cosine of 50. And then I can't forget my reaction moment down here, MO, right? I guess I decided to write this in green. That's going to be plus MO equals 0. And if we did all that, we would get the same answer. That's good. But now we could have another alternative way, and I might need to give myself some more room over here. So here's the way that I would not do it, because I'd be all confused by the angles. And what we do here is drop down a line of action and then figure out what that distance was, right? And that right there would totally be legitimate. It would just be more harder to do. And I don't know about you, but some of the stuff is already hard enough, so it's not worth. I'm not even going to bother with it. It looks like I did actually. Oh, look at that! Check it out. Okay, so I did do it. And I figured out that this was 20 degrees, right? Because looking at that right there was 20 degrees. So what I found was my distance was actually equal to 3 times the sine of 20 degrees right there, right? So I could take my 30 pounds, and so if I took my sum of the moments about O equals 0, take that as positive, and what I would say in terms of I would say, I'm trying to go right here. This thing's trying to go clockwise, so I'll go negative 30 times 3 times the sine of 20, and then I would add in the reaction on there, and I would find my reaction was 30.78 foot-pounds. So you can see 3 different ways to approach the same thing. And some of them are going to be easier than others. Like this one actually wasn't too bad. Once I recognized this angle right there, I was able to get it. And this one was definitely the longest one. That took me the longest amount of time. But it was pretty systematic, and one of the benefits is that I already found out what Rx and Ry. It was easier to find Rx and Ry. So, we could also, by the way, use the cross product, which might be a better thing to do, right? So maybe discard. Maybe I will take the second and just do that. I'll demonstrate it because the video wasn't that long. So if I wanted to do that and find, now once again, this is not going to be the summation of moments. This is going to be this is going to be an example of applying the matrix method onto the thing. We know that the equivalent, right? So this is going to be the MO. That's the equivalent moment. The moment that's equivalent to this force being placed on here. So we start out with our position vector is going to be, let's call it A with respect to O. And that's going to go, okay, so 3, let's write this thing out to the side. And I'll use my calculator here. And I'll say that 3 times the cosine of 50. So, I'll go x, A with respect to O is 3 times the cosine of 50. And I get it's going to be 1.9284. That's way too many. And these are feet. And then y, A with respect to O, is going to be 3 times the sine. And that too is going to be positive as well, right? Because it could go up. So 50 sine 3 times. So that's 2.298 feet. Right, so this position, go black, is 1.928 I plus 2.298 J, and these are feet. And then my forces, right, so I can write out, maybe I'll write it out to the side here, and I'll make them in red because forces are red, right? So we go Fx is equal to 30 times the, and this angle, as we said before, right, because this is 50 right here, and this was 20, so this must be 30 degrees. So that's going to be the cosine of 30 degrees. And so cosine of 30 degrees, is that the one? Is that point? No, it's 0.86. 30 times, and then I go, so that's 25 point, that doesn't seem right. 30 cosine, 30, yeah, okay, 25.98 pounds. Fy is equal to 30 times the sine of 30, which is just half, right? So that should just be 15, right? So writing up here, and these are both positive directions. Oh, I jumped colors, so 25.98 I plus 15.00 J, and these are pounds. So I want to find the equivalent moment is going to be my R, A with respect to O, crossed with F, and this is the F at A, so actually I probably call it FA right here, right? So MO I J K and 1.928 2.298, 0, 25.98, 15.00, and 0. And we actually don't need to do the I and the J. We already recognize that those zeros over here are going to cancel out. So what we're left with is 1.928 times 15 minus 2.298 times 25.98. Okay, and these are going to be foot-pounds. We work that out, and I bet you we get the same thing that we would have got before, right? So 1.928 times 15, boom, that's 28.92. And then 2.298 times 25.98, boom, that's 59.7, and we subtract one from the other, and we get a negative 30.78 foot-pounds, which means that MO is equal to 30.78 foot-pounds. But clockwise, because this is an equivalent moment, it's not a reaction moment. So I think that was worth adding the thing on. And maybe I want to do that in class. Maybe I want to be more selective. But anyway, I've made a video of the thing, so I can refer back to it. If you want to work through this, I think this will really kind of help to congeal those ideas. And it was 16 minutes long.